Welcome back for our interesting next session, Gut Microbiota Towards Clinical Revolution. First of our moderator, there is no need to introduce him. Professor Pinit Kullavanijaya, MB CHB leads, DETM and H from Liverpool, MRCP from UK, FIMS, FAMM, FACG, FACP. FRACP honor, FRCPI, FAMS, FRCPP from Glasgow, Edinburgh, London, and Thailand, respectively. Currently, Professor Pinit is a director, independent director, chairman of the Nomination and Remuneration Committee of Jularat Hospital Public Company Limited. Professor Pinit is also Deputy Secretary, Special Instructor to Gastrointestinal Diseases, Department of Internal Medicine, Faculty of Medicine, Chulalongkorn University, Thai Red Cross Society. Professor Pinit is also Chairperson to Faculty of Medicine, Chulalongkorn University Foundation, and Senate Advisor to Public Health Committee, Senate Advisor to Universal Health Coverage Subcommittee, Senate Advisor to Primary Healthcare Subcommittee. Professor Pinit is also Senate Committee on Emergency Integration on Road Safety, Senate Subcommittee on Emergency Recovery, Chairman of the Working Group on Road Safety Campaign Thai Red Cross Society, Committee of the Reference Group on Global Health, the International Federation of the Red Cross and Red Crescent Societies, Committee of the Health and Climate Working, the International Federations of the Red Cross and Red Crescent Societies, Director of Administration to Ratha-korn International College of Medicine, Thammasat University, Director of Administration to Faculty of Medicine, Chiang Mai University, Emeritus Regional Advisor, Royal College of Physicians of Edinburgh, Honorary Committee to Advanced Security Management Program, National Defense College. Our second moderator is as world-renowned Professor Yoshio Yamaoka, PMD and PhD. Professor Yamaoka is the Vice President and Trustee Oita University, Japan, and is the Chair and Professor of the Department of Environmental and Preventive Medicine at Oita University, Faculty of Medicine, Japan. Professor Yamaoka is also the Professor in the Department of Gastroenterology at the Baylor College of Medicine, USA. Professor Yamaoka received MD and PhD in gastroenterology from Kyoto Prefectural University of Medicine, Japan, and postgraduate training in internal medicine and gastroenterology from the same university. Then he did postdoctoral work in the Department of Medicine section of gastroenterology at Baylor College of Medicine before joining the faculty of the same section. Please give a warm welcome to our board of moderators.
Thank you, MC, for your very kind introduction. Good morning. Welcome to this very interesting and most exciting topic on microbiota. From yesterday's conference, you probably realized that microbiota is involved in almost all diseases, and today as well. And this symposium is also like the gathering of Baylor College of Medicine alumni, because two of the speakers and my co-chair are from there at one time or the other. So without further ado, I would like to ask my co-chair to introduce the first speaker, please.
First speaker is Professor Muhammad Miftahussurur. Usually we call the Miftah. So he got a MD in the Iran University in Indonesia, Surabaya, and he came to my laboratories to get a PhD. And also after PhDs, because usually PhD is a 4 years course. However, he's very excellent, so he got graduated within 3 years. And the fourth year, he moved to the Baylor College of Medicine in Baylor. And currently, he's a professor in Ireland University and also the vice rector of Ireland University. So today's topic is the human gut microbiome controller for wellness and diseases. Okay, so please.
Thank you very much. Good morning, ladies and gentlemen. Thank you very much to all my teacher, Professor Pinit, Professor Yoshio Yamaoka, Professor Vilaichone, and also Professor Ratha-korn Vilaichone. Thank you very much for the opportunity in ASEAN Gastro in this year. And today we will discuss about the human gut microbiome, a potential controller of wellness and diseases. And the kind of this topic is very interesting because we know that the role of gut microbiota and their unique metabolites would be conferring host protections, again, invading pathogen and also regulating of the diverse of host physiological function. However, if imbalance or dysbiosis happen, might lead the dysfunction of host machineries and contributing to pathogenesis and progression toward of a broad spectrum of disease. The million of microbiota live out in our digestive organs. However, three main pillars compose gastrointestinal microbiota, including Firmicutes, Bacteroidetes, and Acetobacter. And all the function expansion 50 until 100-fold more genes rather than human. And many studies found that the crosstalk between the gut microbiota and the host potentially mediated by microbial synthesized metabolites, which exhibit what we call pleiotropic effect. And as mentioned earlier, that microbiota have a multifarious role and function. And in the case neurosystem disorder, gut microbiota has essential role to derive the sort of chain fatty acid in nervous system disorder such as acetate, butyrate, propionate, hexanoate, and also valerate. Ladies and gentlemen, and also indoles, we know that the indoles that we know as essential mediators in the gut-brain axis. The indoles 3-propionic acid are all we call IPA as a powerful antioxidants, inhibitors, and also exhibit neuroprotective and cytoprotective, and can reduce DNA damage and also inhibits of beta amyloid fibril formation. In IBD, the synthesis many microbiota such as Ersipilo, Trichalus, Residuum hominis, and others give the essential rules and by activate host nuclear receptors and also cell signaling pathways. And also when we see the choline metabolites, they have a wide range of function in organism, such as a modulate lipid metabolism and also glucose homeostasis. However, in high concentration in related to cardiovascular diseases and also inflammatory bowel disease and also navel and the activity in bacterial members such as Firmicutes and Proteobacteria also known producers of choline metabolizers. In addition, such as bacteria like Bacteroides, Eubacterium, Enterococcus, and Blautelia engage the conversion of we call glycosylated flavonoids to aglycones and further break down to small phenolic metabolism compound. Ladies and gentlemen, I'm sorry. Yes. When we see the bacteria, they call 100 of can modulating what we call the B vitamins with significant physiological roles in hosts by supporting the fitness of symbiotic species and also suppressing the growth of the competitive species. As we know, this is the polyamines can define of small polycationic molecules with also wide array of biological function, including gene regulation, stress resistance, and cell proliferations, and also differentiations. In addition, gut microbiome have its multifarious function and metabolism. The animals studies show that the dietary fiber has been shown to reduce colon tumor, and gut microbiota produce the butyrate with fermentation of the dietary fiber produced. And as I mentioned before, the gut and microbiota and bile acid correlation, the gut microbiota plays an important role in the co-metabolism of bile acids, and the bacteria such as the Clostridium perfringens and also Clostridium singens have the roles in the secondary for bile acids metabolism. Yes, okay, sorry. Okay. For vitamin K, DMK can be synthesized only by various group of bacteria or archaea. This is including the first step of the traditional and also secondary pathway. And gut microbiome have also metabolism in also in metabolic control. And in this slide, I involve how the energy balance process that microbiome produce differs metabolites and can interact with immune and nervous systems of the colonized host to regulate in energy intake and also expenditure. We can see the GLP-1 and PYY, also SGVA, also NFL3 for regulates the lipid absorption program and microbiome regulated manner, and also including tryptophan. In the next, microbiome act the metabolism of 3 macronutrients: carbohydrate, proteins, and also the fats. Because it also signaling, we can see enteroendocrine cell via microbial metabolites. And gut microbiome also have the multi-function in immunity and also nervous system. In the gut barrier, several commensal microbiome such as Bacteroides, Bifidobacterium, and also Firmicutes are capable the inducing expansion of Treg cells, which are crucial for suppressing pathological inflammations induced by aberrant effector T cells, and also fortifying gut barrier function. And the second one, with the concept of gut-brain axis, it is including complicated direct and indirect interaction of gut microbiota and their metabolites with different cellular component in CNS, and also how also disruption of homeostasis in gut microbiota. And ladies and gentlemen, still related with CNS, the gut microbiota contributes the maturation of progress of naive microglia, and also the number of mature microglia decreases in the absence of microbiota, and we call AMP sensitive microbiota. And beside the interaction between the ENS and gut immune system are essential for GI tract homeostasis, including BMP2, by MMS, we call muscularis macrophage, and also production of GSF1, and BMP2 is dependent in gut microbiota. For colonization resistant, of course, the gut microbia have big roles for niche inclusion, also fermentation product, antibiotic production, and etc. And the next mechanism is how the gut microbiota mediated stimulation or enhancement of host defense mechanism by interact with the local pattern recognition system, or like receptors and not like receptors, also stimulation production of host antimicrobial peptides. And it is we starting with how the microbiota have the relation with some disease such as with the, for example, for CDI. In this slide, we can see shown that one of the proposed mechanism is via the bioconversion of primary bile acid, secondary bile acid that will inhibit the vegetative growth of Clostridium difficile. And that we know the Clostridium difficile is the positive gram toxin and spore producing anaerobe, and also one of the Firmicutes members in normal gut microbiota. Interestingly, antibiotic administration was known to be the major risk factor of CD, and administration in antibiotic also induce microbiome dysbiosis in the pathogenesis of CDIs. Ladies and gentlemen, of course, we know C. difficile infection or CDI-associated symptoms, including diarrhea, pseudomembranous colitis, also death in several cases. So in this slide, we can see that the C. difficile can inhibit by gut microbiota such as C. scindens, and also with the broad spectrum antibiotic induce dysbiosis of C. difficile growth. There is significant reduction if we can see the antibiotical secondary bile acid leading the reduced inhibition of C. difficile vegetative growth, including allowing C. difficile outgrowth and colonization the empty niches, and also leading the higher susceptibility of host towards CDI. In this slide, we showed a study that the recurrent relapse for Clostridium difficile infection, a study informed that of 16 patients with infusion group, and we show the long-lasting elevation of fecal microbiota diversity and high recovery 90% compared to vancomycin narrow-spectrum antibiotic treatment that show recovery rate in 60%. And it showed that rates of cure without relapse for recurrent Clostridium difficile infection. Ladies and gentlemen, I will show about microbiota diversity in patient before and after infusion of donor feces as compared with diversity in healthy donors. FMT has a role to elevate the gut bacteroides and Clostridium cluster 4 and 94A, and reduction the protect bacteria, indicating the importance of dominant microbes in suppressing C. difficile outgrowth. How about the gut microbiota and also inflammatory bowel disease? We know in this bacteria, we call the Firmicutes such as Faecalibacterium, Prosnitzi, and Roseburia species play important anti-inflammatory roles in reducing pro-inflammatory cytokines such as interleukin 12, interferon gamma, and also increasing anti-inflammatory interleukin 10. And also beside that, Firmicutes have an important producer of butyrates, and also therefore reduction in Firmicutes for elicit inflammations by decreasing anti-inflammatory cytokines by SCFA deficiency induced. In the study, I can want to show in the left side that F. prosnitzi was reduced in UC patient compared to control with trend towards significance. And the bacteria in UC patient was significantly lower with median 11.5 than control with median 12.2. And in the right, we can see the count of our hominids was significantly lower in UC patients when compared to control than medians 7.9. Ladies and gentlemen, we also want to show you the gut microbiome associated with celiac disease. We know the celiac disease in multifactorial chronic immune, and the significant decreases in total gram-positive to gram-negative bacteria ratio was observed in all phases of celiac disease patient compared to the healthy controls, and also shown that it will be the roles of bacteria gram-negative, such as Bacteroides Pretophila groups, being universally observed in multiple studies. And the figure about the pathogenesis of celiac disease, that the specific host genetic make up an environment factor could promote the colonizations of pathobionts and reduce the symbionts. And this biosis may contribute the disrupting the immune homeostasis and gut integrity. And in this slide, I will talk about how the contribution microbiota in the etiopathogenesis of CD, because in the microbiota, can influence the intestinal barriers and immune function by regulations of the cytokine network and also pro-inflammatory and anti-inflammatory cytokines. How about in this colorectal cancer? Recent findings suggested that gut microbiota plays a role in the intersections of this factor, probably through shaping of the tumor-promoting environment, and also the sequencing show how the significant enrichment of the Bacteroides fragilis, and also, on the other hand, overrepresentation of gut microbiota may be the driver of the CRC that is non-associated with the colitis or IBD. So the protective effect of probiotic using lactic acid producing bacteria such as lactobacillus and also bifidobacterium against experimentally induced colon cancer, and are also shown the reducing the tumor incidence and also tumor loads. And this slide show that how the role of Fusobacterium nucleatum in the colon cancer, and Fusobacterium nucleatum increase the inflammatory process such as TNF-alpha, interleukin-6, also in the interleukin-8. And also the Fusobacterium could activation the signaling pathway, promotes cellular proliferation, including decrease what we call TOX family, and it is associated with the decrease of apoptosis, failures, DNA repairs, and also increased metastasis. Talk about enterosogenic Bacteroides fragilis, or we call ETBF, stimulate carcinogenesis in colonic epithelium through the BFT toxin, and induce ROS by inducing spermine exudate expression. And also BFT modulates the host immune response by promoting Tregs lymphocyte to respond 17 lymphocytes. And so in this slide, I will show you about the journal which discuss about health and disease markers associated with the gut microbiome composition, thousands of peoples. And this paper analyzed revealed both known and unknown associations. And this figure shows the how examining result the overall composition of the gut microbiome in the study participant, the relative abundance of firmicutes range from 6 until 100%, while the relative abundance of Bacteroides range from 0 to 90%. And this association with insulin level and also microbiome diversities more significantly more pronounced in Bacteroides rich cluster rather than the reference cluster, and the number of vegetables consumed per day significantly more positive associated with microbiome diversity, such as Prevotella. And as you show in the Professor Yamaoka lecture yesterday, we also found the similar background of the gastric microbiota for upper gut microbiota in our several study. Ladies and gentlemen, as the message today, three taken, I can convey the end of the session. Number one, gut microbiota have multifarious function for metabolism, metabolic control, immunity, and the nervous system also in the colonization resistance. Health and disease markers associated with gut microbiome compositions, and some diseases are associated with gut microbiota, such as Clostridium difficile infection, inflammatory bowel diseases, celiac diseases, and also colorectal cancer. Thank you very much.
Thank you very much, Professor Muhammad. You have given a very good overview of microbiota. As you can see, it's related to many diseases, and I think it's promising for the future to learn more things. Next, I think we should proceed to the next speaker, and it is my great honor and privilege to introduce Professor Andrew Chan, MD, MPH, who is a gastroenterologist, and the Daniel K. Podolsky Professor of Medicine at Harvard. He is also Professor of Immunology and Infectious Disease at Harvard T.H. Chan School of Public Health, Chief of Clinical and Translational Epidemiology Unit at Massachusetts General Hospital, and the Director of Epidemiology at the MGH Cancer Center. He leads research in gastrointestinal epidemiology and cancer prevention, mainly on aspirin diet and gut microbiome, on the risk of cancer and other chronic diseases. He is an elected member of the American Society for Clinical Investigation and the Association of American Physicians. He is an American Cancer Society's clinical research professor and an outstanding investigator of the NCI. He is the clinical research counselor on the American Gastroenterological Association Governing Board. Please give us a warm welcome to Professor Andrew Chan.
Well, thank you very much for that kind introduction, and very much honored to be here, and thank the organizers for including me in this wonderful conference. So you've heard a really nice overview of the role of the gut microbiome in a variety of chronic health conditions in gastroenterology. I'd like to focus my talk today on the role of the gut microbiome with colorectal cancer, but in particular, I want to discuss how we can actually understand the role of diet in cancer through the lens of the microbiome as a way to really modify cancer risk in a very concrete way. So this is an outline of what I'm going to be discussing. I'll give you first some background about the role of the gut microbiome in colorectal cancer, where the evidence is, with a real focus on human evidence. I'm also going to discuss specifically our model for how we can link the diet with colorectal cancer via the gut microbiome, and talk about some novel dietary risk scores that we've developed that allow us to potentially develop some preventive interventions for colon cancer. And then I'll wrap it up with a summary. So first, I want to discuss the evidence that really supports the importance of the gut microbiome for colorectal cancer. And we've heard some of this evidence from our previous speaker, but I'll go into a little bit more detail. Because a lot of the evidence that has been really demonstrated to show a potential causal link have been in experimental models. And I'd like to really kind of focus my discussion on where there's human evidence that really supports the importance of the gut microbiome on colorectal cancer, specifically by looking at epidemiological data that links antibiotic use with colorectal cancer, and also the data that really discuss and have shown differences in the microbiome between individuals with and without colorectal cancer. So it's very well known that antibiotics impact the gut microbiome. There's some very specific rapid alterations that happen when someone's exposed to antibiotics. That includes a loss of microbial diversity, a shift in specific communities, with a decrease in firmicutes, a decrease in bifidobacteria, an increase in Bacteroides, an increase in proteobacteria. There does appear to be relative similarity across antibiotic classes, and there are some variations by individual factors. And we do know that human evidence has shown that when you're exposed to antibiotics, there is some perturbations that are demonstrable and repeatable across individuals. And sometimes you will see permanent loss of beneficial bacteria. So here is some original evidence looking at the use of antibiotics and risk of colorectal adenoma. And this was data that we generated from a prospective study conducted within a cohort of female nurses that are enrolled in the United States, in which we collected detailed information on their use of antibiotics across the life course, and also subsequently identified whether they were diagnosed with a colorectal adenoma. And this was work led at the time by one of my postdoctoral fellows, Yin Cao, which showed that if you were a person who was exposed to antibiotics frequently between the ages of 20 and 39, those individuals that had at least 2 months of exposure to antibiotics during that time period had about a 1.4-fold higher risk of adenoma compared to those that were not exposed to antibiotics. And if you were exposed to a similar level of antibiotics between the ages of 40 and 59, you had about a 1.7-fold increased risk of colorectal adenoma. This has been subsequently validated by a range of other studies looking at antibiotic use in colorectal cancer in other cohorts. This was data from a meta-analysis which combined these studies that showed pretty clearly that there was a tendency toward an increased risk of colorectal cancer with chronic antibiotic use. And one of the junior faculty in my group, Mingyang Song, also conducted this study back in 2021, where he looked at data from the Swedish national registries, where there is very detailed information also antibiotic use. And what he found also was that antibiotic use, particularly broad-spectrum antibiotics, was associated with about a 1.2-fold higher risk of colorectal polyps compared to those that were not taking antibiotics. So there's fairly compelling data that this very strong disruptor of the microbiome does associate with chronic risk of colorectal cancer and colorectal adenoma. Now, what about other human evidence? Well, a lot of this evidence has really relied on characterizing the gut microbiome in cases of either colorectal cancer and adenoma compared to controls. And I wanted to provide a summary of where data are up to now. There have been a host of different case control studies in different cohorts, ranging into very small studies with about 20 cancers and 20 controls to larger studies with 203 cancers and 236 controls. But you can see quite clearly across these different case control studies that there does seem to be specific differences between bacteria in patients with either adenoma or cancer compared to controls. And in particular, I want to highlight very consistent findings, in particular, of increases in specific species like Bacteroides fragilis and also Fusobacterium across many different studies. And so Fusobacterium, I think, is perhaps the bug that's the most well characterized with respect to its association with colorectal cancer. So why is Fusobacterium potentially mechanistically linked with colorectal cancer? It's known to be a gram-negative anaerobic bacteria commonly found in the oral cavity, and it's been shown to be enriched in the tissue and also fecal samples of colorectal cancer. And this was a summary of 7 different case control studies where metagenomic profiling of cases to controls was done. And you can see across the different bacteria that were enriched in carcinoma, Fusobacterium was the one that was the strongest. So Fusobacterium does appear to be a very important player in the pathogenesis of colon cancer. It's also been linked to poor colorectal cancer specific survival and resistance to chemotherapy. And it's also been associated with specific subtypes of colorectal cancer, specifically right-sided tumors, tumors with BRAF mutations, and sometimes tumors with hypermutation or microsatellite instability. What's the potential mechanism linking Fuso to cancer? Well, it's known that Fuso is in the oral cavity and can transit to the gut and to the colon. And in this particular environment, it may potentiate the tumor's immune evasion. It may allow the tumor to evade native anti-tumoral immunity. And also, it may stimulate colorectal cancer-specific growth directly by activating beta-catenin via adhesin FAD1. So this is a mechanistic summary of the microbiome colorectal cancer link. So we can see here that microbiota probably have multiple mechanisms by which it may influence carcinogenesis. It may alter the balance of host cell proliferation and death. It also may alter the immune system function and also alter host and microbial metabolism. When it comes to specific bacterial organisms, I've been focused on Fusobacterium, but there's also linkages again with other bacteria. The most well-established are Bacteroides fragilis, and this mechanism is felt to be related to DNA damage, as well as by E. coli PKS positive strains, which seems to promote intestinal inflammation. And in addition, there have been data linking a microbial bacteria that specifically produce short-chain fatty acids and may actually be a protective factor against colorectal cancer. So switching gears, how do we then link diet and colorectal cancer to the microbiome? And the reason for this has been twofold. One is that there's very strong evidence linking diet to colorectal cancer, and there's also strong evidence linking diet to the microbiome itself. So diet is an important factor for both, and this was a study that was done in 2018 that showed that a very large variance in the microbiome could be explained by diet, up to 20%. In addition, we know that at least 40% of colorectal cancer risk may be attributable to dietary changes. So it stands to reason that these two findings may be linked together. So our hypothetical model was that potentially you have this linkage between diet and the gut microbiome and diet and cancer that could be mediated by gut microbiome through alterations in host metabolism and immunity. And there are a variety of potential mechanisms by which this may occur. Diet's been known, for example, to induce the production of short-chain fatty acid producing bacteria that may be protective. In addition, there's linkages between certain dietary components and the production of bile acids, which may be harmful to the gut, as well as the production of various metabolites like choline, which could lead to production of TMAO, and that may also cause metabolic disturbances that predispose to cancer. What I want to focus on, though, is this particular link, which is between specific areas of diet, such as red and processed meat, with production of inorganic sulfur compounds in the colon. This, in turn, may feed the generation of sulfur-producing bacteria, and hydrogen sulfide-producing bacteria could indeed lead to DNA damage. So how do we then link these dietary patterns with colorectal cancer, again, using human data? So what we did was a study of the linkages between Western diet and colon cancer and prudent diet and colorectal cancer. It's been well established that Western dietary patterns, which are diets that are high in saturated fat, low in fiber, and high in sulfur-containing amino acids, may be linked with colorectal cancer. And so our model was that maybe these Western diets could increase sulfur-producing bacteria, which could lead to hydrogen sulfide, inflammation, and genotoxicity. In contrast, a prudent diet, which is consisting of a diet high in whole grains, fiber, and vegetables with glucosinolates, could lead to the production of myrosinase-producing bacteria. These bacteria produce other sulfur compounds that tend to be protective against cancer, such as isothiocyanates. In addition, we also know that shifts to a Western diet may be associated with an increase in the abundance of sulfogenic bacteria, such as Fusobacterium. So to conduct this analysis, we use data using a dietary pattern factor analysis, where we can take dietary data collected through a food frequency questionnaire and conduct a principal component analysis, which results in basically a generation of a prudent pattern and a generation of a Western pattern. Our model was that diet was potentially linked to colorectal cancer via Fusobacterium nucleatum. And this was data that was generated by Raj Mehta, who was a postdoctoral fellow in my group at the time. And he used data from two large prospective cohorts. One was the Nurses' Health Study, which is comprised of over 121,000 female nurses that were enrolled in the US starting in 1976 and were followed for dietary intake every 2 to 4 years over the last 30 plus years. In addition, we used data from a parallel cohort of male health professionals that were enrolled in a very similarly structured study where they gave us dietary information every 2 to 4 years over the last 30 years. Using this dietary data, what we then looked at was, subsequent to that collection of dietary information, who was diagnosed with colorectal cancer. We confirmed 3,000 cases of colorectal cancer across the two cohorts over the last several decades. Among the cohort, we were able to collect tumor tissue from 990 different individuals, and then we did qPCR, or the NUSG gene of Fusobacterium nucleatum, to characterize those tumors that tended to be generated from a Fusonucleatum positive mechanism versus those tumors that were not. We found that Fusobacterium nucleatum levels tended to be higher in colon cancer tissue compared to adjacent normal. And this is what we found. So looking at the association of Western diet and colorectal cancer according to whether the tumor expressed fuso, we found that individuals in the highest quartile of a Western diet actually had a modestly increased risk of a fusobacterium negative colorectal cancer. In contrast, if you looked at fusobacterium positive cancers, individuals that were in the highest quartile of a Western diet had about a 1.7-fold increased risk of a fusobacterium positive tumor compared to those in the lowest quartile. Looking at it with respect to prudent diet, individuals that had the highest quartile of a prudent diet, or those people that ate the healthiest foods, didn't have an appreciably different risk of fusobacterium negative tumors compared to those in the lowest quartile. But if you looked at people in the highest quartile of prudent diet, they had about a 60% reduced risk of developing a fusobacterium nucleatum positive tumor compared to those in the lowest quartile. So this really suggests the fact that there might be an association of a prudent diet and a Western diet with fusobacterium nucleatum specific colorectal cancer. We've also subsequently done analyses looking at this in association with colorectal cancer survival and found that people with a fusobacterium positive tumor, seen here in red, have worsened colorectal cancer specific survival. There also tends to be differences in fusobacterium positive tumors with respect to whether there is high T cell density in tumor tissue, again supporting the fact that fuso may have a linkage with anti-tumoral immunity. What about other components of diet? Well, as I mentioned, the sulfur microbial diet is another potential influencer of colon cancer risk given the generation of genotoxic hydrogen sulfide. Again, high sulfur containing amino acids in red and processed meat may lead to the generation of H2S in the gut, which could lead to a variety of damaging effects to the colon. So we conducted a novel study using microbiome data that we've collected in the health professionals follow-up study. And this is work led by Long Nguyen, who is a junior faculty member in my group. Within the health professionals follow-up study, we did a sub-cohort where we took 308 men within this cohort and collected stool specimens, 2 consecutive bowel movements, 24 hours apart, and then 6 months later, another 2 consecutive bowel movements. With this stool collection, we then isolated nucleic acids and conducted shotgun metagenomic sequencing to characterize what bacterial species were there and what their functional profile was. We cataloged specifically 43 sulfur metabolizing bacteria via a pathway search and lit review, and we were able to use this data to then develop a sulfur microbial diet score, in which we used the dietary information collected in this cohort to identify what dietary components led to a microbiome that had high sulfur microbial scores. And this tended to be a diet that included high levels of processed meat, low-calorie drinks and liquor, and also sweets and desserts. And what did we find? So we looked at this sulfur microbial diet and tried to understand, does it associate with an increased risk of colorectal cancer? So within the health professionals follow-up study, we found that overall, there wasn't a substantial increase in risk by the highest quartile of sulfur microbial diet, but of overall colorectal cancer, but there was an increase in distal colon and rectal cancer, such that those individuals that had a high sulfur microbial diet had about a 1.4-fold higher risk of a distal colon cancer compared to those in the lowest quartile. We've also looked in a cohort of both men and women. This was work led by Yiqing Wang, who is a postdoc in my group, and she also found a very similar association with distal and colorectal cancer in another cohort of women, suggesting that this is a validated finding across different cohorts. And then finally, we were interested to understand, could this also be a potential explanation for the rising epidemic of early onset colorectal cancer? So we conducted a study within a cohort of younger nurses, the Nurses Health Study 2, in which we looked at the sulfur microbial diet with early onset adenomas, defined as those adenomas diagnosed before the age of 50. And we found that indeed, individuals in the highest quartile of the sulfur microbial diet had a 1.3-fold higher risk of an early onset adenoma compared to those in the lowest quartile. So where does that leave us with respect to future directions, and where does this sort of leave us with respect to our understanding of diet and cancer? Well, I hope I've been able to show you that there really is very compelling evidence that links the gut microbiome to colorectal cancer risk. In particular, there is this association between diet and colorectal cancer that could be mediated by the gut microbiome. So making this linkage is important because then it allows us to potentially have a modifiable factor by which we can sort of improve the gut microbiome to a state which may be associated with lower colorectal cancer risk. Specifically, we've shown that prudent dietary patterns are associated with lower risk of Fusobacterium nucleatum positive cancer, and a Western diet appears to be linked with a higher risk of Fusobacterium positive cancer. In addition, we've shown a novel diet which predicts carriage of sulfur-reducing bacteria is associated with the risk of distal colon cancer, which suggests that if we can sort of develop dietary pattern scores that tend to predict which kind of microbiome will be generated that could be protective against colorectal cancer, we could have a strong influence on subsequent colorectal cancer's risk, including potentially risk of early onset colorectal cancer, which is a growing epidemic in the US and many other countries. So I'd like to acknowledge the members of my group for which this work would not have been possible. This has been a work led by specifically Yin Kao, Raj Mehta, Long Nguyen, Mingyang Song, and Yiqing Wang, who generated much of the data that I showed you today. I also want to recognize Shuji Ogino, who is our molecular pathologist that's done much of the work on characterizing our tumors, both for immune infiltrate and also for Fusobacterium nucleatum status. And I'd like to thank my funders, as well as acknowledge the participants in all of our studies for which this data would not have been possible. Thank you very much.
Okay, thank you very much for your very excellent talks, especially the focus on the diet. So the next speaker is Ratha-korn Vilaichone. He is now the president, professor in the, also the chief Center of Excellence in Digestive Disease of Thammasat University. Also assistant to the rector in Academic Affairs, Thammasat University, Thailand. And also in this meeting, so the so-called SMG, so he is now the scientific chairman of this meeting. Today's he is more clinical part, so-called a very famous FMT, update on clinical practice. So Professor Vilaichone, please.
Thank you so much for your kind introduction. So my talk gonna touch on the clinical applications of the FMT from the bench to the real world. So my talk gonna consist in 20 minutes with the milestone of the FMT, how we can restore the normal microbiota. What is the roots in the clinical practice for the FMT? For the FMT that we use right now in the C. diff, that very well established. For the IBD, for the multi-drug resistant organism, for the IBS, gonna be the expand more indications. I believe that many of you is gonna know the FMTs very well, but now we have a GMT. What is a gastric microbiota transplantation? So let you know a little bit more about the GMT, the microbiota research and the clinical applications. And finally, we're gonna collapse together in a summary part. For the milestone, as Dr. Asman from Open Biomes talked to you yesterday, they have start to have the FMTs since the ancients of the Chinese medicine. And the big change is going to be in 2013 when the US FDA has approved the treatment of the FMT in the C. difficile infections and start the FDA workshops. And after 2014 until now, they have many new FMT indications going to being explored. So what is the fact about the human gut microbiota? You maybe heard from Professor Mita and Andy's about many of the gut microbiotas in our GI tract systems. In fact, we have around 100 trillions, around 10 times to 12 or more than 2,000 species microbial cells. And mostly gonna contain with the two major phyla is the Bacteroides and Firmicutes, and they can influence the human physiologies, metabolisms of the nutrition and the immune functions. When you disruptions of the gut microbiota, this has been linked with the GIs and the extra GI diseases. Colon contain the highest microbial density, and 99% of the gut bacteria came from around 30 to 40 species. Humans' gut microbiota have around 100 times as many genes than the human's genome. What is the role of the gut microbiotas? I believe that they're going to have two important roles, the metabolic roles and the protective roles. For the protective roles, they're going to go to the inactivations of the bacterial toxin and stimulations of the immune systems, the barriers to protections against the pathogens. And for the metabolic roles, they're gonna go to the regulations of the metabolic functions of the host. They're gonna have to control the food metabolisms and the biosynthesis of the vitamin. So when is the good times to develop of the gut microbiotas? That they have many studies suggested that the first few years, especially for a 1000th day of your life, is very important. It's a period of establishment of the individual gut microbiotas and shaping it. So as I can see, the pediatric gastroenterologist here, so the first few years of life is going to be the most important for developing of the gut microbiota. How we can restore of the normal microbiotas, as many of you know about the disperses. Whenever we want everything back to normal by using FMT, they're going to have a direct pathway and indirect pathway. For the direct pathway, they're going to have a phage and the bacteriocins, and they're going to have a direct transfer of the short chain fatty acid and the nutrient compositions. For the indirect pathway, they're going to have a bile-acid metabolism and the short chain fatty acids metabolisms. Then they're going to change the disperses back to symbiosis and improve the disease with the eradications of the multi-drug resistance, for the treatment of the C. difficile, treatment of the IBD and IBS, and the last not least, treatment of the metabolic syndrome. What is the root of the FMT in our clinical practice? We have an NG tube. My goodness, I believe that someone here is going to use the FMT by the NG tubes. Somehow they may get the aspirations and some smell. But anyhow, the very first of FMT, they use a lot in the clinical practice. And then we're going to have a regional enema that we use a lot in our clinical practice. We have a lower GI endoscopy. And the last but not least one, we have encapsulation. Very first mentioned before, the FMT is very effective for the C. difficile infections. When you have a healthy colons, whenever you use a lot of antibiotics in the cleanup of the microbiotas and turn the overgrowth of the C. difficile, and then might be turned to be a Pseudomonas colitis. When you use the FMT, we like to bring the disperses back to the symbiosis. They can restore of the stable, healthy gut microbiotas and back to the normal of the colon again. For the FMT of a C. difficile is going to have two meta-analysis in Cochrane reviews published in the Red Journals in 2013 and systematic reviews published in the Annual Internal Medicine 2015. The overall cure rates of the FMT in the C. diff is approximately 85 to 90%. With the upper J root, it's approximately 70 to 80%. Lower J root is around 90%, and enema approximately is 80% with a very few of the adverse events. Very interesting about the treatment of the FMT for C. diff. It published in New England Medicine 3 or 4 years ago. It's a study from Norway. Not treatment in the patients with the primary C. infections, but the treatments mostly in the primary, not a recurrent one. They're going to randomize the assign for 20 adult patients with acute C. diff and positive C. difficile infections in the stool. 11 patients going to receive the oral metronidazole and 9 going to for the FMT. Interestingly, even it's not statistically significant. You can see that in the FMT part, they have a full clinical response more than the metronidazole group. That is just like very impressive to show that the treatment without the chemical medicines may be improved. The treatments even in the primary C. difficile infections. Anyhow, they can still have a dark side of the FMT treatments. From study with Elizabeth Holman, is an Andy friends in Harvard Medical School. We just met each other last month and talked a little more about how to get the best treatment without the less complication. So Professor Holman and group demonstrated that they have 2 patients with the E. coli ESBL after the oral encapsulations. The first patients with the Hep C cirrhosis and another ones with the MDS. And unfortunately, in the MDS patients, the patients die. So this is going to lead us to enhance the donor screening. Just talked to Francis Chan yesterday that sometimes E. coli SBL is very common. Professor Chan said in Hong Kong it's around 80%. So it's very important to screen, aggressive screening the donors before we can go to the transplantation. And we have to define the benefit and the risk of MT, especially in the immunocompromised host. For summary of the FMT for C. diff infections, in 2022, we have two guidelines. The first one from the ACG guideline recommend that the FMT should be used for the severe antibiotic resistance of the C. diff infections. And the guideline published from the IDSA and the SURE suggests that FMT is appropriate management for the recurrent C. difficile infections after the standards antibiotic treatment. How about experience in ASEAN country? 1 year back, we report the FMT for treatment of the primary C. diff in our centers, and we actually we gave many patients receive the FMT by the enema, and the response is very good. After 1 to 2 days after the FMTs, the diarrhea is going to be less, and we can discharge the patients within 2 days. How about the study, the new study about the FMT and the C. diff? That they have a publication in Lancet Gastro in this September 2022 about the FMT for the first or second C. diff infections. This is a randomized double-blind placebo-controlled trial. They grabbed 42 patients randomized to receive the FMT capsules and the placebo after receive 125 milligrams of oral vancomycin 4 times daily for 10 days from University Hospital at Denmark. And this study suggested that in patients with first or second C. diff infection, the first line with the FMT is highly active and superior than the standard vancomycin alone. How about the FMT with the IBD? Professor Miftah let you know a little bit about the treatment with the FMT in the IBD. They have many studies, and a good study published by Paul Majority Groups, Rosen Group, Param Sotis, and Castellello in 2015 to 2017. They're going to be the double-blind randomized control trial with many tens of the patients. And they're going to use the FMT by the lower or upper GI endoscopies with a single donors. The follow-ups are around 6 to 12 weeks. The primary endpoint is going to be the endoscopic remissions, and we found that approximately 30 to 40% of the patients going to respond for the FMT. However, the new publications just published in Gut in this August in 2022, they mentions about the FMT with a very special diet they call the anti-inflammatory diets or FMT-AIDS. Following the anti-inflammatory diets alone is very effective in inducing and maintains remission over a years. This is very impressive. Normally, we know that with the FMT, sometimes they have to use a multiple treatment, and they cannot last long for many months. In these studies, they grabbed 66 patients with the mild to moderate UCs, were randomized to receive the FMT with a special diet or the standard medical therapies. What is a special diet? Special diet, this is mean from the avoidance of the gluten diets and avoidance of the dairy products or margarine, or avoid of the processed and the red meats. And they're gonna use the FMT for 7 times weekly from the fresh FMT with multiple donors from week 0 to week 6 with anti-inflammatory diets. And the study suggests that combination with the FMT and the anti-inflammatory diets would be very effective and safe, and maybe can have a maintenance remissions over a years. How about the FMT with the MDROs? We're gonna first observe in the feces of the patients after FMT for the recurrent C. difficile infections, they have a number of antimicrobial resistance genes decreased. For the FMT, it might be increased the Bacteroides and Firmicutes and can reduce the proteobacteria and can transfer and produce bacteriocins that reduce some pathogens, especially the VRE and the CRE. For the MDR, again, they're going to have many studies since 2017 from many groups and many tens number of the patients. The treatment regimen is going to be the single FMT, and the target multi-drug resistance is going to be the capsular, the VRE, and the CRE. Route of transmission is mostly going to be the upper GI with a duodenal tube, and the primary endpoint is going to be complete decolonizations at 6 months after the FMT, and the response is going to be around 30 to 80%. Recently, we have a publications in Biomedicine in this September 2022 about the efficacies and the safety of the FMT for clearance of the MDR or under multiple comorbidity. They're going to test the FMT effectiveness and safety in eradications of the CRE and VRE, intestinal colonization. This is a study from Professor Kim countries from the South Korea. And they suggested that 3 months and the cumulative overall negative conversions rate were significant higher in the FMT group. This might be a clinical significant that we can use the FMT to use in the multi-drug resistant organism. How about the FMT with the IBS? They're going to have many studies since the late of 1980s. Many of the studies coming out in several groups of study from the case report to the randomized control trial. For our experience, we just present this study in DDWS San Diego this year about the effect of the FMT on irritable bowel syndrome. And this is a randomized placebo-controlled double-blind studies. This time we use many types of the IBS. The first 10 going to receive the FMT by the barium enema, and the second 10 is going to receive the placebos. Fortunately, we suggested that the FMT via the rectal enema improve the overall clinical response, the IBS severity scoring system, or the IBS SSS, and the quality of life score. And we suggested that FMT might be an alternative effective treatment for patients with the IBS. And recently, if you've done a lot of research, you're gonna know Dr. Mahdi El-Sahati very well. He is from Norway and very early to treat FMT in the clinical practice, especially from the IBS. We just met each other in Scotland in the European Helicobacter meeting. At the time, he presented data of the FMT about the IBS and just published in Gastroenterology in this June 2022. Professor El-Sahati groups use 125 patients and 38 going to receive placebo. 42 receive a 30 gram of the FMT and 45 is going to receive a 60 gram of FMT. Feces is going to administer to the distal duodenum via the upper GI endoscopies. And they found that even a single of the FMT is very effective and safe interventions and can sustain the effects for at least 3 years. So this means that this is might be, for me, it's very interesting that we can use FMT and make a clinical sustaining response more than just like for a few years. To summary of my talk, what is the potential therapeutic target of the FMT and the clinical response right now? So we know the C. diff well established and very promising is in the level of evidence 1 for the MDR, or it's just like a multi-drug resistant in the clinical evidence 2, for the ulcerative colitis evidence 1, Crohn's disease for the level of evidence 2. For many of the functional constipation or the IBS, they're gonna have a level of evidence of study around 1 to 2. Parkinsonism is gonna be level 4. And the last at least one for the weight loss, Francis Chan showed that yesterday we can use alopecia patients with the FMT, right? But our next step, even in Thailand right now, so we have many patients with obesity. FMT might be the next choice. How about the FMT in Thailand? We start first around in 2018. At that time, we have a visit at the FMT labs in McMaster's University, at the Open Biomes, and at the MIT with our good friends, Professor Eric Arms. And while the back to Boston trips, we back to Thailand and start the FMT stool banks. You might know the Open Biomes very well from Dr. Osman yesterday. To summary, before the COVID-19 infections, Open Biome is a non-profit stool bank that uses more than 700 centers in all states of the United States. And believe me, before COVID-19 infections, the stool delivered for the FMT from the Open Biome is 25,000 kilograms a year, a huge one. How about stool bank in Thailand? We're going to establish, as mentioned before, in 2018. We established the stool bank because we like to consistent screening and testing and processing the treatment unit. And the safety assessment of donor is very important. talked to Francis Chan yesterday. Sometimes we have a very tough time to screening the one donor. To be honest, we just only have 2 donors in our center, and we can lower costs. And the last but not least, we can provide the FMT used in the emergency condition. This is our labs in our centers. FMT is in the BSL level 2. And this is a sample of the stool delivery when we deliver to the patients. So we just got a Boston trip with Andy Labs last month, and we also back to MIT to meet our good friends and with the Open Biomes, and believe that we're going to have a research cooperations with Open Biomes to sign the MOU together very soon. Our new achievement is we can do the FMT encapsulation. We use the FMT around 50 grams in the drip freezers, and then we use a lyophilization technique. We call freeze dry and make it a very small, blend it to very small pieces, and then we make as a capsules. Maybe you can guess how much if you want to capsule from Open Biomes. Huh? Andy, have you bought before? My goodness, it's Open Biome. If you like to buy a capsules, for 25 capsules for a single use, it's going to be $2,000 US. Professor Macro, you like to get one? My goodness. So in our labs, after we tried a lot, we can make the capsules successfully, and we can lower price to around a few hundred US dollars. How about the FMT study in Thailand? Right now, as we move, as mentioned, we have presentations in DDW, and believe that in next years in Chicago, we're going to present our data about the FMT encapsulation in the IBS patients. 1 hour, GI fellow can start the FMT in a fatty liver and for the obesity with a metabolic syndrome. Professor Pinit, we just talked yesterday, somehow we don't have to use the whole feces for transplantations. They published in the New England Medicine early of these years. They use the SIR 109. What is the SIR 109? This is a live purifier of the female cutis bacteria spore. They use a 4 capsule daily for 3 days compared to the placebo treatment of C. diff, and the response is very well. So in the future, maybe no FMT, it might be the certain of the bacteria, just like a microbiota transplantation. And as mentioned in very first, that we have the GMT. What is the GMT? It's a gastric microbiota transplantations. Right now, they have a study from South Korea from Professor Kim again, just published in the Gut, and they used the gastric fluid from patients with the chronic surgical gastritis from the IM and gastric cancers and inoculated to the 42 germ-free mice and analyzed for 1 year. They found that the GMT from the human patients can induce the pre-malignant conditions of the mice stomach, and I believe that they're going to have human studies very soon. Mr. Chairman, ladies and gentlemen, for my summary, FMT is gaining increasing prominence and actively studied in a wide range of conditions. Role of the FMT in the clinical practice, we know very well about the C. diff, and we're going to expand more indications in the IBD, in the IBS, in the fatty livers, and the multi-drug resistance. Restorations of the normal fecal microbiotas may be important for resolving many diseases refractory to the medical treatment. Thank you so much for your kind attention.
Thank you very much, Professor Ratha-korn. That was most interesting. I have 3 questions from online first, if I may, can get rid of that quickly. First question is to Andrew. Please come on stage, all of you. Andrew, which group of bacteria play most important role in the development of cancer? Which group of bacteria play the most important role in the development of cancer?
So the bacteria that have been most strongly linked so far include Fusobacterium, Bacteroides fragilis, and PKS positive E. coli. Those are the 3 that seem to be the most strongly associated through experimental models and also mechanistic work. The human data, I think, are particularly strong for Fuso, but increasingly, I think those other bacteria are also being looked at more strongly in human studies.
Thank you. Next question to Professor Ratha-korn. What is your recommendation for FMT in immunocompromised hosts? In fact, Francis yesterday answered it already, but please.
So I think this is very good questions because we know that for the FMT, sometimes they can have some bacteria left in the feces material, such as the E. coli SBLs. And Professor Holman's good friends of Andy is going to report in Lancet Medicines this year. So I believe that we have to aggressive monitors and aggressive screening of the stool donor before we can deliver to the patients. And this might be very safest way. And in our labs, we use an interval. I mean, that sometimes it's very expensive. I believe that Francis knows very well. We cannot screen every week or every single of the FMT. Sometimes we use just like an interval of times to make sure that the feces is safe enough to deliver to the patients. I would like to know from Francis, do you have any experience, any suggestion from the FMT in Hong Kong?
Microphone, please.
Thank you. In fact, in Hong Kong, like many other FMT centers in the world, we follow a standard protocol to screen all our potential donors. First of all, we start this clinical screening, look for those important clinical parameters that make the potential donor not suitable. For those potentially suitable candidates, we follow a whole set of laboratory screening. In particular, I believe in this part of the world, screening for ESBL positivity is very important. Because, for example, in Hong Kong and many parts of Asia, its ESBL positivity is up to 80% or even higher. So it's unlike the United States. And they make identification of potentially suitable donor a lot more difficult compared to the US.
Thank you. The third question is for Muhammad and Andrew. How would you see the trends for FMT in terms of colorectal cancer prevention and in patients with colon adenoma? Mohammed first, please.
Okay, thank you. The current fact is they do the current condition, not the follow of the study with the prospective study, I mean. So I think it is need the further investigation to follow some study with the prospective study to know the precancerous of the colon cancer and follow the study until know the exact rules of the microbiota. As such as of gastric microbiota, our study used the condition in intestinal metaplasia and also gastric cancer, and also we compare with chronic gastritis. In this case, it is, I think, very difficult to say that which one is the first. The chronic gastritis change the microbiota, or microbiota truly induce become the intestinal metaplasia and gastric cancer. And if we think about adenoma and also colon cancer, I think it is need more evidence, and with additional FMT in the treatment of the colorectal cancer, probably we can get the evidence. It's truly the gastric microbiota change after the disease happen, or they truly induce and show an association in the colorectal cancer. Thank you.
Andrew, anything to add?
No, I think that is a good summary. I think that the challenge really with FMT for cancer is the studies are difficult to do because cancer is a very slowly evolving disease. So it's very hard to have an FMT study where you have cancer as the endpoint. Adenoma could be a potential alternative, but even then, I think you're really talking about longer term studies for adenoma prevention. So I think it's going to be a bit of a challenge to really have that kind of clinical trial evidence to support FMT for cancer prevention.
Any question or addition from the audience? Please, Francis. Microphone, please.
I have two questions. The first question is to Andrew. I'm very much interested in this self-photogenic diet, and you mentioned that in the future we probably need to develop some kind of dietary score to guide our kind of patients with regard to what kind of diet is less or more carcinogenic. I just wonder how practical it is, because diet is so complicated, and can you share your insight with us? And my second question is, I know that here in Asia, people are very enthusiastic about the use of FMT beyond recurrent C. diff. But I understand at the same time that FMT is being regarded as an investigational drug, IND, in the US, and probably the same principle apply to different Asian countries, even though the regulatory, the regulations might be different. So how are we going to uphold this standard that we are not doing human experiments without control? How can we ensure the standard of this IND when we try to extend the indications or even clinical trials beyond recurrent C. diff?
So with respect to the first question, diet is a challenge for sure, I think, in terms of being able to have patients adhere to the right diet. I think one of the advantages of developing a microbiome tailored diet is that you have the ability to use the microbiome as a biomarker to assess adherence to a diet, and also give some feedback to the patient as to whether they're doing the appropriate thing to sort of improve their diet. I think one of the challenges with diet is that there's not enough feedback between to the patient to really let them know whether they're doing the right thing. So one of the areas that our lab has been interested in is personalized nutrition, trying to understand, can we personalize diet so that maybe you can use a surrogate endpoint like microbiome profile to guide a patient to adjust their diet accordingly, to make it more easy for them to actually eat foods that they enjoy. I think the second question about FMT is a good one, and I'd like to hear what other people think also, but it is a very big challenge in the US. I think the FDA is very, very negative toward FMT, and so they've been making it very challenging for people to do experimental research, as you mentioned, with FMT, and there's a lot of back and forth in terms of how what kind of guidelines people need to follow in order to provide FMT to patients, which makes it much more difficult than even a pharmaceutical product. So I agree. I think there needs to be some changes because it's such a novel area and such a novel treatment that the FDA has really not been able to catch up with the science.
Anything, Francis?
Just a very quick answers to Francis' questions. I think this is one of the important questions when we did a lot of the SMT research. To be honest, when we talked to Open Biome, even the biggest stool bank in the US, the only indications that approved by the US FDA is a C. diff treatment. Even for the recurrence, even for the first treatments may be not enough right now. So I believe that if we have more evidence, just like RCT trials in the future, we can expand the indication and can be accept more from the many FDA from many countries of the world.
I think time is up. I would like to thank all speakers very much and my co-chair. Thank you very much indeed.